Meet Maya. She's at the school fair, trying to choose between two different containers of popcorn. One is tall and skinny, the other is short and wide. Same price? Which one holds more? Maya thinks the tall one wins, but she's about to get the surprise of her life. Today, we're cracking open one of math's coolest secrets: why, when it comes to cylinders, the radius is so much more powerful than the height. Let's go. Before we solve Maya's popcorn problem, let's make sure we know our shapes. A cylinder has two circular bases, top and bottom, connected by one curved surface. Think of a soup can or a basketball hoop tube. Two measurements matter most: the radius, which is the distance from the center of the circle to its edge, and the height, which is how tall the whole cylinder stands. Both matter, but one matters way more. We'll get to that in a second. Here's the magic formula. Volume equals pi times r² times h. Let's break that down. The base of a cylinder is a circle, and the area of a circle is pi times r². Then we multiply by the height to stack up all those circular layers. Think of it like stacking a tower of coins. Each coin is a circle, and the more you stack, the taller it gets. V equals pi r²h. That r² is the key player today, and here's why it's so powerful. Here's the big secret. Notice that r is squared, meaning we multiply the radius by itself. That little exponent 2 is incredibly powerful. If you double the height, the volume doubles. Simple enough. But if you double the radius, the volume gets multiplied by 4 because 2 squared equals 4. The radius affects the volume exponentially. So when Maya is choosing her popcorn container, a wider radius matters way more than extra height. Let's see this in action with some real numbers. Let's figure out Maya's tall, skinny popcorn container. It has a radius of 3 inches and a height of 10 inches. Plugging into our formula, V equals pi times 3² times 10. First, 3² is 9. Then 9 times 10 is 90. So V equals 90 pi, which is approximately 282.6 cubic inches. Maya's looking at that number and thinking, not bad. But wait until she sees the wide container. Okay, let's calculate that one next. Now the wide, short container. It has a radius of 6 inches, double the first one, but only half the height, 5 inches. Let's calculate. V equals pi times 6² times 5. First, 6² is 36. Then 36 times 5 is 180. So V equals 180 pi, which is approximately 565.2 cubic inches. Wait, that's almost double the tall container. Maya's jaw tops. The short, wide container holds nearly twice as much popcorn, even though it's only half as tall. The radius wins every time. Let's really drive this home. Because r is squared in our formula, every change to the radius gets amplified. Double the radius and you multiply the volume by 2², which is 4. Triple the radius and you multiply by 3², which is 9. That's why Maya's wide container, with double the radius, holds about 4 times the base volume compared to the tall one. Height only scales linearly, 1 to 1, but radius scales exponentially. Now Maya knows exactly which container to grab every time. Let's try a bigger example, a water tower. Maya's class is studying their town's water tower, which has a radius of 7 feet and a height of 20 feet. How much water can it hold? V equals pi times 7² times 20. First, 7² is 49. Then 49 times 20 is 980. So V equals 980 pi. Multiply 980 by 3.14, and we get approximately 3,079 cubic feet. That's a lot of water. Maya's teacher is impressed. Maya solved it in under a minute using the formula. Now let's work backward. This is where math gets really cool. Maya's friend Jordan has a cylinder with a volume of 628 cubic centimeters and a height of 8 centimeters. What's the radius? Start with 628 equals pi times r² times 8. Divide both sides by 8. That gives 78.5 equals pi times r squared. Now divide by pi, which is 3.14. R squared equals 25. Finally, take the square root of 25, and r equals 5 centimeters. Working backward from volume to radius, Maya and Jordan both nailed it. Let's lock in our process so you can solve any cylinder problem with confidence. Step 1, identify your radius and height. Those are your two key numbers. Step 2, square the radius. Multiply it by itself. Don't skip this step. Step 3, multiply that result by the height. Step 4, multiply everything by pi, which is approximately 3.14. Follow these steps every single time, and you will not go wrong. Maya writes this checklist in her math notebook and circles step 2 because squaring the radius is where the magic happens. Here's your chance to try one yourself. Pause the video right now and give it a go. We have a cylinder with radius 4 centimeters and height 9 centimeters. Ready? Let's solve it together. V equals pi times 4 squared times 9. First, 4 squared is 16. Then, 16 times 9 is 144. Finally, 144 times pi is approximately 452.2 cubic centimeters. Did you get it? If you did, boom, you are crushing it. If you need to rewatch, that's totally fine. Every math star has to practice. This isn't just a math class thing. The r-squared effect shows up everywhere in the real world. When a pizza goes from 10 inches to 14 inches in diameter, it's not just a little bigger, it's almost double the area because of the radius squared. Engineers designing water pipes know that a slightly wider pipe carries dramatically more water. Even when you upgrade from a small cup to a large at the movies, the volume difference is bigger than you think, all thanks to that radius. Maya now looks at cylinders everywhere with new eyes. Remember when Maya was staring at two popcorn containers, completely confused? Now she's the one explaining cylinder volume to her whole class and choosing the better deal every time. Here's what we learned. Volume equals pi times r squared times h. Always square the radius before multiplying. And the radius is so much more powerful than the height because of that squared exponent. You've gone from zero to cylinder hero today. Next time you see a can, a cup, or a water tower, you'll know exactly what's going on inside. Keep practicing. You've totally got this.